Good morning. Today we are going to discuss about the electromagnetic waves. So everybody we know about the electromagnetic waves, which are constituted by the periodic variation of electric and magnetic fields. Though these two fields are separate, yet they are closely related to each other. These waves propagate in such a way that the electric and magnetic fields are perpendicular to each other and also perpendicular to the direction of propagation of waves. Thus, the electromagnetic waves are transverse in nature. So we know in sound waves, water waves, waves in stretched strings, etc., the particles will move, whereas in electromagnetic waves, the particles will not move. Only the energy can be transferred, but the particles cannot be moved. This is the speciality of electromagnetic waves. Therefore, only the field intensities will change in electromagnetic waves. The figures which related to the electromagnetic waves was given in the figure. Radio waves, water waves are given there. So Maxwell equation predict the existence of electromagnetic waves which propagates in free space, that is called as a vacuum with the velocity of light. Electromagnetic theory is the scientific theory that is used to explain the electromagnetic waves, their properties and application. Here we are going to discuss about the Maxwell equation and its mechanism, how it is involved in the propagation of electromagnetic waves in free space and if any of the material medium along with the laws that govern these equations. Then Maxwell equations we have to discuss. There are 4 Maxwell equations are there. To find the 4 Maxwell equations, we need to know the important basic laws and theorems for electromagnetic waves. The first thing is the Gauss law for electric field. So we know everybody what is Gauss law. So Gauss law for electric field states that the total flux 1 by epsilon naught, that is enter into the closely surface, is equal to 1 by epsilon naught times of the total charge q enclosed in the surface. That is the closed integral of closed surface integral E dot ds is equal to q by epsilon naught. Here q is called as the total charge and 1 by epsilon naught is the total flux. The figure shows clearly that is the square type. It is a magnetic material. It is a material medium. The red and blue color waves indicates the magnetic field lines, how it is penetrating into the material. The next law is Faraday's law. The Faraday's law states that the induced electromotive force, that is epsilon, in a coil is equal to the rate of change of magnetic flux linking in the coil. That is, epsilon is equal to minus d phi by dt. Here the negative sign implies that the decreasing in magnetic flux. The third law is the Ampere-Circuital law. Ampere-Circuital law states that the line integral of magnetic field B surrounding any closed path is equal to mu naught times of net current passing through that path. That is, closed line integral B dot dl is equal to mu naught I. Otherwise, we can rearrange this equation. We can bring the mu naught in the left side. So, we can get B by mu naught dl is equal to I. Here H, we can write the H, that is magnetic flux, that is B by mu naught. We can write the above equation as instead of B by mu naught we can put H. So closed line integral of H dot dl is equal to I. The fourth law is Gauss law for magnetic field. The first law we know about the Gauss law for electric field. Here the same thing we have to do for the magnetic field. The Gauss law for magnetic field states that the magnetic flux passing through the closed surface is equal to 0. That is, this is the main important equation which has to be remembered Remember, everywhere, that is the closed surface integral B dot ds is equal to 0. So everyone can understand, for a closed surface it may be circular or it may be sphere or it may be rectangle or it may be square, anything. If the surface is closed, whatever the magnetic field enters into the closed surface, it should be 0. It should be considered as a 0. This is the main thing. It is a significance. The next one is the divergence. Everyone, we know about the divergence, that is the amount of spreading out of vector point from the source. It is called as a divergence. The definition here, it is for the electromagnetic wave is the divergence of a vector f at a point P is defined as the change of vector, that is mean expansion per unit volume as volume, how much it shrinks to 0 about P. That is divergence f, that is del dot f. We can write it for all the x, y, z axis. So dou fx by dou x plus dou f by dou fy by dou y plus dou fz by dou z. The next law is a curl. So we need to know what is curl. The measure of twist of the vector with respect to a point is called the curl. Example, if a pen or pencil, anything we having, we are going to rotate with our finger, that is called as the curl. It may be in clockwise or it may be in anti-clockwise. So the definition for proper electromagnetic wave, the curl of a vector A vector at a point is defined as the amount of twisting or a circulation per unit area around that point. So curl A is called del cross A. So here also we need to write for all the 3 dimension. The x, y, z axis have a unit vector I cap, j cap and k cap. So del cross A is equal to modulus of I, j, k and dou by dou x, dou by dou y and dou by dou z. The field vectors are ax, ay and az. The next theorem is a Gauss divergence theorem. This theorem is used to convert a surface integral to volume integral and also volume integral to surface integral. Wherever we need to convert, we can use the Gauss divergence theorem from surface to line or surface to volume or volume to surface. So it states that the volume integral of divergence of vector A is equal to the vector A that spreads out through the surface which covers the volume. So the theorem is closed volume integral of del dot A dV is equal to closed surface integral of A vector dot n cap ds. Otherwise, it can be converted as surface integral to volume integral. Next one, Stokes theorem. This theorem, the same opposite for the Gauss divergence theorem, that is the another one closed integral is line integral. So we have to convert the line integral to surface integral. Otherwise, from surface integral to we can convert into a line integral, means we can apply Stokes theorem. The statement of the Stokes theorem is the line integral of a vector f around a closed contour is equal to the surface integral of curl over the region which is bounded by the contour. That is, the closed line integral f dot dl is equal to closed surface integral del cross f into n cap ds. So mostly the 8th theorem is very important one. The remaining 2 is that is equation of continuity. Some derivations have to be found out for this equation of continuity. That is, we need to know the final equations enough to derive the Maxwell's 4 equation, that is del dot j plus dou rho by dou t is equal to 0. The equation of continuity, once again I will say, the equation of continuity is del dot j. Here j is called as a current density and dou rho plus dou rho by dou t. Here rho is called as a current charge density del dot j plus dou rho by dou t is equal to 0. This equation is called as a equation of continuity. The another one, the last one, is a Poynting vector. It's a very important definition. It is defined as the amount of energy flow of electromagnetic wave per unit area per unit volume along the wave propagation direction. It is denoted by S vector and is given by S vector is equal to E vector cross H vector. Here E is called as a electric field and H is called a magnetic field. So in this figure we have mentioned how the Poynting vector directed and how the electromagnetic waves is propagating according to this Poynting vector. So we are clear about this theorem and laws which is used to derive the Maxwell equations. Now we can move to the Maxwell equation. So the Maxwell equation was framed by the theory of electromagnetic radiation, which is derived by James Clerk Maxwell in 1865. So he explained about the fundamental relation between electric and magnetic fields. These four equations are called Maxwell equation. The four equations have name. The first equation is called as the Gauss law for electricity. The second law of Maxwell equation is called as a Gauss law for magnetism, and the third one is called as a Faraday's law of electromagnetic induction, and the fourth one is called as a Ampere's law.